Let's just talk about a couple of limitations on this, which are going to get us to the Fourier series in just a minute, okay? For this integral to exist, this Fourier transform, we don't actually want infinites, right? Because that's not so good when we try to like write down infinity. It just goes a really long time, all right? One thing we could say is that this whole thing is integrable, okay, if the original function itself is integrable. That is, if I take the function, I actually take its absolute value, if I sum it up from minus infinity to infinity, it can't explode. It has to be limited to a value. So you might ask, but wait a minute, I thought we had infinite repeating series.
I thought we had infinite repeating series.
We did when we were talking about Fourier series. We're now talking about the Fourier transform, where we're trying to keep things bounded. So the idea is that these integrals have to exist. It's based on the same principle, but it's this idea. So in Fourier series, we talked about repeating functions. In Fourier transform, we're talking about integrable functions, all right? In a minute, when we have a fixed length function, it'll be clear. In fact, let's get to that right now. You see it says, so obviously, if there was a bound of width t, right, so if all my entire function fell within t, then obviously I could just integrate from sort of negative t over 2 to plus t over 2, right? That would be the entire integral. And that's going to lead us, at least in my twisted mind, to this notion of the discrete Fourier transform.